once we've separated our bounded context into these nice, clean boundaries, we have a bit of a job ahead of us, which is maintaining those clear boundaries, maintaining the purity of those bounded contexts. So we need a technique or a set of techniques that allow us to do that. So one way that we do that is with something that we call an anti-corruption layer. When we have our bounded context, it's important to recognize that each bounded context may have domain concepts that are unique. If we look, for example, in this diagram, we have our reservations context and our customer context. Now, there are certain aspects of a customer that are unique to a customer. They don't matter to the reservations. Address is an example of that. In addition, there are concepts that are not always compatible from one context to the next. What happens sometimes is you may end up with a concept, for example, that is called one thing in the reservations context and is called something different in the customer context. Or, you may end up with situations where something is not compatible in such a way that it requires a translation of some kind. Maybe it's recorded in different units or something like that, and we need to translate it. So the point is that you can end up with situations where things are not compatible between these bounded contexts. What we don't want is we don't want to just come up with sort of an abstraction or some way to make it the same across all bounded contexts, because what that does is it causes one bounded context to bleed into another. So for example, if we just said, well, you know what, we have a customer representation that includes all the details. It includes address, phone number, when they became a customer, lots of details about that customer. We could just use that representation of a customer everywhere, and then we don't have to worry about that. But that creates coupling that we want to try to avoid. So for example, if we were to do that, and then we were to go in and change the structure of an address. Maybe it was represented one way, and then we realize there's a better way to represent it. We include additional information, or we remove some information. Well, if we've used that everywhere, then now we need to go and we need to update the reservations context, even though the reservations context doesn't care about the address. And so now we've created an unnecessary coupling. And so we want to avoid that. And the anti-corruption layer allows us to avoid that. What it does is it looks at whatever that customer context representation is, and it translates it into a representation that is unique to the reservation service. So it strips out the unnecessary information like address. If there's any kind of language translation that has to happen, it does that. And as a result, the reservations context only deals with the pure representation that it cares about. So this prevents bounded contexts from leaking into each other, but it can also allow it can also allow our bounded context to stand alone. If we have, for example, a caching layer inside of that anti-corruption layer, then what can happen is if the customer context disappears for some reason, then the anti-corruption layer still may have a cache of that information and still may be able to operate, despite the fact that the customer context is gone. Now, how is that anti-corruption layer implemented? A common way to implement it is as an abstract interface. The abstract interface represents sort of the pure domain representation of the data. And then we have an implementation of that interface, which does the necessary translation. And that's sort of an infrastructure component that does that translation. So this is in the situation where we have pure bounded contexts. Our reservations context and our customer context are fairly pure. We understand their boundaries fairly well. That's not always the case. Sometimes you have to interface with a legacy system. Now, with the legacy system, the domain may be messy or it may be unclear. Nobody may have taken the time to understand the domain of that legacy system. So in this case, an anti-corruption layer has the job of keeping the mess of that legacy system out of your pure bounded context. It prevents your domain from having to deal with that mess. Now, in this case, we have our anti-corruption layer in two places. We have it both in the reservations context and in the legacy system. You can see it in both places. Technically, you could put it in either place or both. What I would generally recommend is anytime a pure microservice or a pure bounded context has to communicate with another external service of some kind, it should do so through an anti-corruption layer. So the reservations context should always have an anti-corruption layer to communicate with an external service. Now, on the flip side, in your legacy service, what you may want to do is, because of the complexity of it, you may want to expose an API that is just for the reservations context, which then has a bit more of a pure representation. It's not totally pure, but it's a bit more cleaned up from what your messy legacy system would typically be exposing. So you might expose that in the legacy system in order to help. But even when you do that, I would still recommend having the anti-corruption layer on the reservations context side as well. Now, you may have noticed that these diagrams that we've been drawing have these sort of bubbles with the name of a bounded context in them, and then we've got arrows going between them. This particular kind of drawing is what we call a context map, and it's a way of visualizing bounded contexts and the relationships between them. We're going to use this technique in some of the exercises, so we're going to introduce it here so that we have an understanding of it. Now, we've drawn these context maps using these kind of loose bubbles. It's not important what the shapes are. If you want to use rectangles or blobs of some other shape, it doesn't really matter too much. But what you're trying to do is you're trying to draw these shapes and then draw arrows showing the relationships between them. It's sometimes helpful, we haven't done it, but it's sometimes helpful to label the relationship. So when you draw those arrows, you might label the relationship saying, is it a dependency? What kind of dependency is it? That kind of thing. Typically, though, what you're saying in this case, in this diagram, would be that bounded context A has a dependency on bounded context B and bounded context C. That's kind of what these arrows indicate, is a dependency of some kind. And so again, if you want further detail, you can label the arrow to indicate the nature of that dependency or the nature of that relationship.